I'm going to discuss about pyroelectric sensors. Myself, Dr. R. Balamurugan, Associate Professor in the Department of Electrical and Electronics Engineering, KS Rangasamy College of Technology, Tiruchengodu. Let's we explore into the slides. So basically, we are going to see about pyroelectric sensors, its introduction, its construction and cross-sectional view, its operation, and how it will be helpful for measuring the temperature fluctuations, and how can we are converting the measured quantity in terms of giving temperature to the user side, and some applications. Right? We will go with the introduction initially. So what is the basic principle of pyroelectric sensors is nothing but pyroelectric effect. So this sensor is an IR sensitive optoelectronic component, which is specifically designed for electromagnetic radiation wavelength of 2 to 14 micrometer. So any temperature fluctuations can produce charge change on the surface of the crystals, which is present on the pyroelectric sensor. So that pyroelectric crystal will create a corresponding electrical signal with respect to the temperature fluctuations. If the temperature gradient is created due to the absorption of light, the crystals will give some charge change. That charge change is represented in terms of temperature variations. Let's we see the cross-sectional of a pyroelectric detector. This is nothing but cross-sectional view of a pyroelectric detector. Here, the diagram which is shown here is nothing but having your broadband filter cap with the compensation element and pyroelectric element at the center part of the sensor. So other allied circuits are connected with that in order to convert the measured quantity to the readable one of temperature. So here the next diagram shows the market readily available pyroelectric detector with the electrodes. So this pyroelectric element plays a major role here. It absorbs the IR rays. The IR rays absorption of IR rays is converted into heat here. That heat will produce the surface charge changes, and that charge changes will induce the temperature fluctuations, and it can be measured through the upper down electrode of the pyroelectric detector. How does a pyroelectric detector works? Pyroelectric crystals have a rare asymmetry due to their single polar axis. This causes variation of temperature due to its polarization. This ever we call it as a pyroelectric effect. So in the sensor upper side of the sensor, a pyroelectric crystal is coated with perpendicular to the polar axis of electrodes, and a black layer is pasted on it. It absorbs the IR rays, and heat will create the temperature changes on the black layer. That black layer will interact with the IR radiation and heats up the pyroelectric layer. Pyroelectric layer, when it is heated up, surface charge changes will be created. That surface charges initiates the temperature measurement. So when the radiation is switched off, a charge opposite polarity will be originated at the surface of the pyroelectric crystal. Ever the charges will be low, the internal resistance of that material will be kept in order to equalize the charges of that layer. And we will ever use field effect transistor and operational amplifiers for converting the charges which is produced on the surface into signal voltage. This signal voltage are later measured with the help of the signal conditioning circuits, and temperature is measured at the last. So like thermal detectors of pyroelectric material, thermoflies also does the same function of thermal detection. Here uh, thermal detectors like pyroelectric IR detectors have a good signal noise up ratio up to modulation frequencies of 4 kHz. Pyroelectric detectors can detect the radiation from the ultraviolet range up to 100 nanometer through visible IR wavelength range up to 1000 micrometer. Next, we see the applications of pyroelectric detectors. So pyroelectric detectors finds major applications in gas analysis, flame detection, spectroscopy, pyrometry, and motion detections. So in contrast to the thermophile, which is one type of thermal detector, the pyroelectric detectors can also measure high resolution modulation frequencies up to several kilohertz. For example, it allows the usage of Fourier transform infrared spectrometers for measuring them. Short laser pulses of order of nano or microseconds is also detected by using these pyroelectric sensors. Thank you for listening. Thank you. These are the references. Thank you for watching.